Hi there, my name's Dylan, and today I'm going to be presenting my senior design project, which is wing construction for model aircraft. My senior design team is composed of 3 members, including myself. Andy's on the left in that picture, and Kyle is on the right. We wanted to find out if laser cutting, CNC milling, or 3D printing could be used to make the wing construction process for model airplanes a little bit easier and more streamlined. We worked pretty collaboratively on this project, but we had a few specialized roles. Kyle had a lot of experience with 3D printing, so we kind of took charge of that wing. And he had a lot of experience with milling, so he took over that wing. And then I had experience with laser cutting and hand cutting, and so I did most of those. So overall, there's very limited information on how these newer maker technologies have influenced the construction of model wings overall. So we wanted to kind of find out how these new manufacturing methods could improve wing performance and possibly ease construction and overall assembly of the wings. So the main methods that we looked at were laser cutting, which is basically using a laser to cut through a material like wood or plastic, 3D printing, also known as additive manufacturing, which I'm sure many of you are already familiar with, and then CNC milling, where CNC stands for computer numerical control, where basically you upload, you use a program to kind of upload your design, and then the mill itself is basically an automated drill bit, which will then go through and cut out the part that you want. So the basic anatomy of a wing is shown here. The spars and the ribs kind of act as the skeleton for the wing. They give it its shape. And then the leading edge and the trailing edge are basically the front and back of the wing respectively. And those are important to be very smooth and very clear of any sort of imperfections, because it's going to really affect the aerodynamic performance of the wing. And then wing tips go on the end, and they also just improve the general aerodynamic performance. So our general assembly process that we followed for each wing was to first lay out our spars and connect all the ribs to them. The ribs have to be pinned in place for this process, otherwise it'd kind of fall over while you wait for the glue to dry. So once that was all dried, you could attach the leading edge, the trailing edge, and the centerpiece, which is where the wing would connect to a fuselage. And then once that was dry, you could flip it over. You would have to remove the rib stabilizers because they were only there for assembly. And then you can put on the leading edge, trailing edge on the opposite side. And then if you were actually going to fly the wing, you'd obviously put a skin on it, which we showed here as an example. We put skin on one of our wings, but as we weren't actually flight testing our wings, we decided not to put skin on all of them. So the traditional model construction that pretty much all hobbyists use is hand carving wings. Now, this process is very difficult, even for an experienced hobbyist. It would take a lot of time and effort, and it's really more of an art form than anything else. But for amateurs like ourselves, this was an incredibly difficult thing to do because we had to carve out each piece separately, and each of the ribs needs to kind of be the same size and shape. Otherwise, the wing's going to get bent or warped. And so we spent a lot of time trying to carve out all these ribs to be exactly the same, and we messed up a lot. So it was definitely a very tedious and time-consuming process. For our 3D printed design, we actually didn't use the rib spar method of assembly. We made a single part that was just in the shape of the airfoil because the 3D printed material, the plastic, holds its shape a lot better and it doesn't really need all those internal supports. But due to the printer size limitations, we had to basically break the wing up into 9 segments and then assemble them together. And we glued those all together with an acrylic adhesive, which is a lot more preferable to wood glue because wood glue can take a few hours to dry, whereas the acrylic adhesive will be dry in a few seconds. When we designed this, we designed little basically band-aids to make it easier to assemble. And basically you would attach one of these parts on the edge of one segment, and then would provide a nice little spot where you could attach another segment and line it up perfectly, which made it a lot easier to assemble overall. For our laser cut design, the primary parts that we cut out were the ribs, because there's 16 ribs per wing. So it's definitely a lot easier when you have a machine doing it for you. And it also guarantees that they're all the same size and the same shape, which will drastically improve your wing performance. The other parts of the wing, such as the trailing edge, the leading edge, and the wing caps, we still had to make out of balsa because those parts cannot be laser cut due to their curvature. And then for our CNC milling designs, we actually had to optimize our rib shape because the polycarbonate we use is a lot heavier than balsa wood. So basically we use the software that on the leftmost picture there, it kind of shows you the forces on the edge of the rib. It then kind of takes that and it takes out as much material as possible to still be able to support those forces and also be as light as possible. We slightly modified that final design to make it a little bit easier to actually make on the CNC mill and to avoid the chances of it breaking. One of the other problems for our CNC milling design was that in order to make the leading edge, it has to kind of curve and conform to the rib shape. Now that's really easy to do with thin balsa wood because it'll bend really easily, but for plastic, it's not gonna happen. So we ended up carving kind of slots in the piece of plastic to kind of make it easier to fold over the ribs. Overall, we had to assemble this in 3 different pieces because the build plate of the CNC mill was limited to only about a third of our wingspan. So we used 3 pieces for both the spars, the trailing edges, and leading edge. So overall, we made 5 wings in total. We made a handmade wing, a laser cut wing, a 3D printed wing, and a milled wing. And we also had a kit wing, which is what we kind of used to base all of our other wing designs on and kind of ensure that they were all uniform between each other. The primary metrics we used for determining their feasibility was their total weight, which would affect their ability to fly, and the total time and difficulty it took to assemble each wing. We found in terms of weight that the kit wing was by far the lightest at only 169 grams. This is most likely because the balsa wood used in this kit was very light. There's a lot of different types of balsa wood and they all kind of vary in weight, and the balsa we got for our handmade wing and our laser cut wing was a little bit heavier. The handmade wing, the CNC milled wing, and the laser cut wing were all around the same weight, ranging from about 250 to 290 grams, which it was interesting to learn. Our 3D printed wing, however, weighed over 1 kilogram, which was absolutely ridiculous, but that's just because of the very dense and heavy nature of the material used in 3D printing. In terms of total assembly and fabrication time, the 3D printed was the fastest. It only took 1.5 hours to assemble. The fabrication time isn't included in that number because the 3D printing is the only method you could do where you can kind of upload your design, you could leave while it prints and come back later and your part would be done. You don't have to be there the whole time. The other 2 methods, laser cutting and CNC milling, you have to be actually present while you're cutting all these parts out. The CNC mill took the second least amount of time at 9.6 hours, followed by the kit wing at 10.2, the laser cut at 10.7, and then the handmade wing at 22.2, which was absolutely the worst time due to its very difficult nature to make. So overall, our conclusion was that 3D printing is not a feasible method for wing construction due to the overall weight. The plane would not fly. Laser cutting and CNC milling are both feasible, however, due to their total weights and construction times. If you have access to a CNC mill, it's definitely the most ideal construction method because not only does it take less time to actually fabricate the parts and assemble, it's also still as light as a balsa wing. And the plus side is that you get to use an acrylic adhesive to glue this together, which means you don't have to wait as the glue dries to assemble your wing. So it really cuts down on a lot of the waiting and the total amount of time you have to spend working on this. However, even if you just use laser cutting to cut out the ribs, it could still save you a tremendous amount of time as opposed to cutting by hand. It'll also make your wing a lot more accurate and a lot more uniform as opposed to trying to cut each part yourself. So overall, that was what we found out.